I'm Anil Kumar sharing with you solution of a recent paper on derivatives of exponential and trigonometric functions. So in this test paper, we'll have about 10 multiple choice questions followed by 10 communication thinking and application questions. So let's begin answering these multiple choice questions one by one. The first one here is, which of the following is a point at which the tangent to y equals to minus x e to the power of 2x is horizontal? So that means the derivative should be 0, right? So let's find the derivative here. Derivative of this function will be, you can apply the product rule. Derivative of minus x is minus 1. So you get e to the power of 2x with negative sign, plus derivative of e to the power of 2x, which is e to the power of 2x times minus x. So basically that is minus of x e to the power of 2x times 2, the derivative of the top portion, right? The exponent. Now for horizontal asymptote, this derivative should be equal to 0. So if I take this term to the right side, any one of them, well, let's take e to the power of minus 2x common first, then be easy. So let's take minus e to the power of 2x common. We get 1 plus, since we have this negative sign here also, 1 plus 2x, right, equals to 0. So that gives us exponential function is never 0, but the second factor here, 1 plus 2x can be equal to 0 for x equals to minus half. So that gives us one of these two options. Now the idea is to find the y value. So we can say y is equals to minus 0.5 e to the power of, when I say 2 to the power of minus half, it becomes, let me write 2 times minus 0.5. Is it okay? So what we get here is this minus makes it plus actually. I should have written positive here. Okay, because x is minus value. So now we can find the value, which is half of e to the power of minus 1. So e to the power of minus 1, correct? So it is 0.5 times 1 over e, right? So basically times 1 divided by e. Okay, so basically it is equal to 1 divided by 2e, correct? That's the value. So let's calculate. So it is 1 divided by, within brackets, 2e, which is equal to 0.183. So 0.183 is option A for us, correct? So that is how you get A as the answer. The next one here is, what is the derivative of the function y equals to e to the power of 2x minus e to the power of minus 2x? Derivative of exponential functions, as you know, is same as it is times the derivative of exponent, so it becomes 2 minus e to the power of minus 2x times minus 2, so that makes this positive. So we get 2 e to the power of 2x plus 2 e to the power of minus 2x as our answer, right? So let's see where we have this positive sign. It matches with option C, right? So option C is the right answer for the second one. Let's move on. There are 10 multiple choice questions. Question number 3 is, the number of sales in thousands of a product in thousands is given by the function f of t equals to e to the power of minus t square plus 4t minus pi, where t is the day. What is the rate of change of the sales at the time the product hits the market? So we need to find rate of change of the function. Let me rewrite this function a little bigger. F of t is given to us as e to the power of minus t square plus 4t minus pi. All this is in the exponent. So the derivative for this function will be, derivative of the exponent part is minus 2t plus 4. And then we have e to the power of whatever the function was, minus t square plus 4t minus pi. Now we are given f dash of 0. So if t is 0, then what do we get? If t is 0, we get number 4 here. So f dash of 0 is 4. And we get e to the power of minus pi, right? So e to the power of minus pi. So we get 4 over e to the power of pi as our answer, which matches with option C. Question number 4. Determine the equation of tangent to the function f of t equals to 3 times 3 to the power of x at x equals to minus 1. So the derivative of this function will be 3 times ln 3, right? So times 3 to the power of x. So that becomes the derivative of the function. At minus 1, the derivative will be, let's write minus 1 here. So what we get here is 3 ln, sorry, this is ln 3, I'm sorry, ln 3. So 3 times ln 3 times 3 to the power of minus 1. That gets cancelled now, right? So we have 3 times ln 3 times 3 to the power of minus 1 is 1 over 3. So that cancels. So you get ln 3 as your derivative at x equals to minus 1. Now if I write f of 1, f of minus 1 is what? Let's see that also. So f of minus 1 is 3 to the power of minus 1 will give you 3 times 1 over 3, which is 1. So the point here is minus 1, 1. That's the point, correct? So, and we know that the slope is ln 3. So we're looking into these equations. I would like to use the formula y minus y1 to find the equation of line. Let me change the color. So we have y minus y1, which is ln 3, equals to, sorry, y minus y1 is 1. Okay, sorry. So we are using the formula y minus y1 equals to m times x minus x1, because it's kind of given in standard form. So this is a good formula to use. So that gives us the equation as y minus y1, which is 1, equals to m, which is ln 3, times x minus 1, that makes it plus 1, right? Since the point which we found is minus 1, 1, correct? Now we need to just reorganize this to get the right answer. So we have ln 3x. Okay, so let's open this to get this kind of a result. So we'll write all these on the left side. So ln 3x, let's open this. So we have ln 3x plus ln 3 plus ln 3. Y, we can bring it to this side, or we have to match one of this, right? So which is equals to y minus 1. So that is the equation. So if I bring, so this one is minus ln 3x. So if I bring this to that side, if I open this, I get minus 1 minus ln 3. So it kind of matches with 4, right? So that is what it matches with. So if I take this equation, bring all the terms to the right side, then I think I match with this. So we'll do that. So we have y here, taking this with minus ln 3x, that we get the first term, plus y is already there, okay, minus 1, and if I bring this, it is also minus ln 3 equals to 0. So that matches with option D, right? When you take a bracket, they become positive. So I hope that's fine. Question number 5. Determine the x-coordinate for the point for which the tangent is horizontal to the function f of x equals to 2 to the power of x divided by x. Horizontal means derivative is 0, so let's find the first derivative. We'll use the quotient rule, right? So denominator x squared. Derivative of 2 to the power of x is 2 to the power of x times ln 2. And then we multiply that by x minus derivative of x is 1, so we get 2 to the power of x here. That should be equal to 0 for horizontal tangent, right? So that means numerator is 0. We can take 2 to the power of x common. We get ln 2 times x minus 1 equals to 0, right? Since denominator, you just numerator should be 0 for that, right? So equating this to 0, this factor, we get x equals to 1 over ln 2. So option D is the right option. Question 6. Determine the derivative of y equals to cosine 1 over x. Derivative of cos is minus, so we get minus sine 1 over x times the derivative of inside function, which is minus 1 over x squared, correct? So these two minus actually makes it positive, and so we have 1 over x squared sine 1 over x as the derivative. Option A is the right option, right? Let's move on. Question number 7. Determine the derivative of sine e to the power of 2x. So the derivative is, for sine it is cosine e to the power of 2x, then times derivative of inside function, which is e to the power of 2x times 2. Right, so that becomes the answer for us. So it is positive 2e to the power of 2x cos. So option C is the right option. D. 8. Determine the derivative of y equals to minus 3 tan minus x minus 4. Okay, so tan is secant square x. So derivative in this case is minus 3. Secant square x value is minus x minus 4 times derivative of inside function, which is minus 1. That will basically make this positive. So we are looking for positive 3 secant square all this, so which is option B for us, correct? So we get option B as the right option. Question number 9. Determine the derivative for y equals to tan x cosecant x. 4 choices are given. It seems we need to apply the product rule to find the result. So let's use product rule. Derivative of tan x is secant square x, because secant square x times cos x plus derivative of cos x is minus sin x. So we could write minus sin x first here times tan x. So minus sin x tan x cos x secant square x. So A is the right option. Question number 10. Determine the equation of tangent to this curve. Y equals to minus 3 tan 0.5x at x equals to pi by 2. So let's also find the value of y at x equals to pi by 2. So y equals to minus 3 tan, this is half 0.5, so we get pi by 4 here. Pi by 4 is 1, so value of y is minus 3 at x equals to pi by 2. So the point is y equals to minus 3, right? Now let's find the derivative of this function. Derivative of this function is y dash equals to minus 3 times 0.5 secant square x by 2, right? That is what the derivative is. At pi by 2, if I substitute pi by 2, I get value of, so it is minus, let's say, minus 3 by 2. Let me write like this. Secant square, if I write pi by 2, it becomes pi by 4. Let me write secant square pi by 4. So if you look into this triangle, pi by 4, 1 square root 2, secant square is 2, right? So we get 2 here. So with that, we get our result as minus 3. So to find the equation of tangent line, we are looking at slope of minus 3, and the point is pi by 2 minus 3. So that gives you the equation, which is y minus y1. So minus 3 makes it plus 3, equals to m, which is minus 3 times x minus pi by 2. Bringing these terms to the left side gives us, this becomes positive. So we have 3x. We can write 3 times x minus pi by 2 plus y plus 3 equals to 0. Or we have 3x minus 3 pi by 2 plus y plus 3 equals to 0. And so we could rearrange 3x plus y, and we have 3 minus 3 pi by 2 equals to 0. So that matches with the option right here, option A, right? So that becomes the equation of tangent line for the given function at x equals to pi by 2. So we're done with the multiple choice questions. Here, question number 11. Is it possible to draw a tangent with slope negative half, this is negative 0.5, is negative half, on the curve y equals to ln x? Explain. You can always pause the video, answer these questions, then look into my suggestions. So when we're talking about ln x, the function is drawn like this, right? It is always an increasing function. Do you see that? It is always increasing. So we could never have negative slope, right? So the answer is no. Since ln x is always increasing, slope cannot be negative, right? Cannot be negative, right? 12. Explain what is wrong with the following reasoning. Y equals to 2 to the power of x, dy dx is x times 2 to the power of x minus 1. Well, we cannot apply power rule when exponent is x, right? So power rule is applied when exponent is a real number, right? Not when it is a variable. Okay, so what will be the derivative? Well, the derivative of this function will be 2 to the power of x ln x, ln 2, right? So that is going to be the derivative of this function, not what is mentioned there, correct? Question 13, true or false? The slope of e to the power of x at x equals to 0 is 1. Prove. So y dash is e to the power of x, and y dash at x equals to 0 will be e to the power of 0, which is 1. So that is true, right? So it is true. Perfect. Now let's move on, and we'll take up some derivatives. Question number 14. Determine the derivatives of following function. F of x equals to e to the power of 0.5 x squared. So the derivative will be 0.5, which is half. X squared derivative is 2x, and e to the power of 0.5 x squared, right? So that cancels. So we get x times e to the power of 0.5 x squared as the derivative. The second one here is f of x is minus 2x times 4 to the power of x. We'll apply the product rule. So we get the derivative as derivative of the first function, which is minus 2 times 4 to the power of x, plus derivative of the second function, which is 4 to the power of x ln 4 times minus 2x. So it could be written as, we could take minus 2, 4 to the power of x common, and we get 1 plus, now we took this minus common, so we get 1 plus ln 4 as our answer, right? So let's do the part C, which is f of x is equal to sine of cos x squared. So the derivative for this function will be derivative of sine x is cosine x. X in this case is the whole thing, which is cos of x squared, right? Times derivative of inside functions. You could write d dx of cos of x squared, right? Okay, so that gives you cos of cos x squared times this derivative is negative sine of x squared times 2x. So that becomes your final derivative. Let's rearrange and write it as minus 2x. We could write this as sine of x squared times cos of cos x squared, right? So that becomes the derivative of the given function. Okay, so let's move on. We are almost at the end. Question number 15. Determine the absolute extrema of the function f of x equals to x minus 3 e to the power of x on the interval minus 1. X is between minus 1 and 3. So to that, we have to find the value of the function at the two extreme points and also at any other critical point in between. So let's find the critical number now. So critical number basically is a point where the derivative is either 0 or it does not exist. So the derivative of this function is equal to, we'll apply the product rule. Derivative of x minus 3 is 1, so we get e to the power of x plus x minus 3 times e to the power of x. Now if this derivative is 0, what is x? Let's figure it out. E to the power of x is common. We get 1 plus x minus 3, and that gives us e to the power of x is common. We get x minus 2. So the critical number is x equals to 2. Now to find maximum, absolute maximum and minimum, we'll find the values of this function at minus 1. We can substitute that here. So we get minus 1 minus 3 e to the power of minus 1. That means over 3. So we calculate this. We'll calculate at 2 the value of the function, which is 2 minus 3 e to the power of 2. And then we'll also calculate at 3. So at 3 it will be 3 minus 3 e to the power of 3. Well, that is 0, correct? We'll calculate the other values. So minus 1 minus 3 is minus 4. So we have minus 4 divided by e is equal to, this is equal to minus 1.47. The other one is 2 minus 3 is minus 1. So we have now minus 1 times e square which is equal to minus 7.38, right? So comparing these values, we have maximum at 3. So we have absolute maximum is at 3. The value is 0. I could write this as 3, 0. And absolute minimum is is at 2 and the value is minus 7.38, right? So that is how it can be answered. So I hope that helps. Question number 16. Determine the equation of tangent to the curve y equals to sine 2x plus pi by 3 at x equals to pi by 3. So at x equals to pi by 3, let us find the value of y. So y will be equal to sine of 2 times pi by 3. So we can write this as 2 times pi by 3 plus pi by 3, right? So which is y equals to sine of 2 plus 1, 3 pi by 3. 3 pi by 3 is sine pi, and sine pi is 0. So the point is x is equal to pi by 3 and y is equal to 0. Now to find the equation, we need to find the slope. So let's find the first derivative. First derivative of this function will be cos of 2x plus pi by 3 times derivative of inside function, which is 2. Let me write here 2. So that becomes the derivative. Now derivative at x equals to pi by 3 is what? So derivative at x equals to pi by 3 is 2 times cos 2 pi by 3 plus pi by 3, which is pi as we saw. Cos of pi is minus 1, right? So if you remember, the graph for cos is like this. So cos at pi is minus 1. We'll substitute that value. So what we get here is minus 2, right? So the derivative is minus 2. So we can say slope is minus 2 at this point. Okay. Once we know the slope, we can say y minus y1 equals to m times x minus x1. That's the linear equation given a point and slope. So y minus y1 is 0. That is the y-intercept. You could use slope and intercept form. That was better. Anyway, so what we get here is, So y minus 0 equals to m is minus 2, x minus pi by 3, right? So let's bring it to this side. So we get 2 times x. When you open this bracket, you get minus 2 pi by 3 plus y equals to 0. Or you can write 2x plus y minus 2 pi by 3 equals to 0, right? So that becomes the equation of tangent line for the given function at x equals to pi by 3. Perfect. So let's move on. 2 more questions to go. Question number 17. The decay of a certain substance is modeled by the function n of t equals to 100, 3 within brackets, 3 plus e to the power of minus t by 3, right? So let me write the function here. We are given n of t equals to 100, 3 plus e to the power of minus t over 3. That's the function. Represented by n in a time of t hours. Number of particles is represented by n. What is the initial number of particles? You can always pause the video, answer these questions, and then look into my suggestions. When I say initial, that means t equals to 0. If I substitute t equals to 0 here, what do I get? So the value n of 0 is indeed equal to 100 times 3 plus e to the power of 0, which is 1, right? So we get 3 plus 1. Let me show this work. 3 plus 1, which is 400. So the initial number of particles is 400. Part B. Determine the rate of change of the number of particles in time t. So we need to find the derivative of this function. So I prefer to write this function as, let me show you, n of t could be written as, let's open the bracket, 300 plus 100 times e to the power of minus t over 3, right? So actually this is a better equation, easier to work with. It clearly gives you why we got 400 answer. Now we'll find the derivative. So the derivative of this function will be, this is a constant, so 0. So here we get negative t over, negative 1 over 3 of 100 e to the power of minus t over 3, right? So that is the derivative. How fast is the number of particles changing when t equals to 3? So let me substitute 3 here and do the last part. So that is at 3, it is minus 100 over 3 e to the power of minus 3 over 3, which is minus 100 over 3e is your answer. Is that okay? Number of particles per hour. So the answer is minus 100 over 3e particles per hour, right? So you can actually calculate the decimal value also. So we have 100 divided by 3 times e, which is equal to 12.26. So that is 12.26 negative, yeah, particles per hour. Okay, so that is how it should be solved. Now we are in the last question, which is find the absolute maximum of the function y equals to, let me rewrite the function here, it's not very clear, e to the power of minus x squared. Find the absolute maximum of this function on the interval minus 2 and 2. So we'll find the critical number y dash, which is derivative of exponent, which is minus 2x times e to the power of minus x squared. Now if that is to be equated to 0, then it is possible at x equals to 0. So the x equals to 0 is our critical number. To find absolute maximum, we'll find the value of the function at x equals to 0. So y at x equals to 0 will be e to the power of 0, which is 1, right? Anything to the power of 0 is 1. And then we'll find the value of these two limits. So y equals to e to the power of minus 2 square. Minus and minus becomes, we'll do that later. First let me do 2, right? So 2 square, this is for x equals to 2. And then we'll also calculate, let me mark it like this. The value of this function, e to the power of minus 2 square. So both are same values because this becomes positive, you can see, right? So at x equals to 2. So both are same values. Is it okay? So we'll just calculate this value. So it is 2 square is 4 basically. So we are looking for y equals to e to the power of minus 4. Right? So we say 1 divided by e to the power of 4. Which is equal to 0.018. Right? So that's a positive value. You can clearly see that the absolute maximum is at x equals to 0. So we have our answer that absolute maximum is 1 at x equals to 0. Right? So that is how you can solve this question. I hope you understand and appreciate our effort in solving this particular test paper. It gives you a variety of finding derivatives of trigonometric and exponential functions, some applications, and mainly equation of tangent lines for given points and also extreme values. I hope it is helpful. Feel free to write your comment, share your views, and if you like and subscribe my videos, that'll be great. Thank you and all the best.